Greetings and welcome, friends. We're taking a look at Kuta worksheet, right triangle trig, trig. And the first question, it says, find the value of the trig function indicated. So let's see, for cosecant theta, let's actually, from theta's perspective, let's practice just our names. So 24 is the hypotenuse. This side right here is going to be the opposite leg because it's the one that doesn't touch theta, so this is the opposite. And this one is the adjacent leg because one of theta's sides is that side, right? So this is the adjacent. Now, so if I'm trying to figure out cosecant, you might have memorized the cho, sha, cow. I don't know. Maybe you did. And cosecant is the reciprocal of the sine function. All right, so that's why it's going to be this one right here. So cosecant of theta would equal the hypotenuse over the adjacent. So that's 24 divided by 16 square root of 2. Now, we've actually got a little bit of work we can do here. I could actually start partially canceling. Between 16 and 24, 8 goes into those. 8 goes into 16 twice and into that 3 times. And I guess I'll write this down one more time just before I start getting rid of the radical. And we're not allowed to have a square root in the denominator, so to get rid of it, I could multiply by rad 2 over 2, or rad 2 over rad 2, which is equal to 1. So that's why it's an allowable, a legal move. So 3 roots of 2 over 2 times root 2 times root 2. Now root 2 times root 2 is 2, right? You could think of that as the square root of 2 squared, which is 2. And 2 times 2 is 4. Can I cancel these out? No, because one's in a radical with an index of 2 and one is not. So that would be my kind of simplified version of that, so to speak. All right, next question, a little bit tougher. Question 29, the instructions said, find the value of the trig function indicated. All right, now for this one, I'm going to recommend actually drawing a picture. So we're looking for secant, but we're given sine. Secant is not the straight reciprocal of sine or anything like that, so I can't just make that leap and just be like, oh, I'm just going to flip this. If it was cosecant, I would. But let's draw a picture just to make things easy. And I don't know necessarily the size of this triangle or anything, but let's see. If this is theta, sine theta is opposite to hypotenuse. All right, so by drawing a picture, it's going to help us out. So the opposite must have been 3 roots of 13, or at least when it had a ratio with the hypotenuse, it must have had that particular ratio. So if I want to now find secant theta, now secant theta, you could have said is 1 over cosine, and cosine is the reciprocal, or is the ratio of adjacent to hypotenuse. Or I could just say secant theta is equal to hypotenuse over adjacent, right? So I'm going to have to figure out what is this adjacent side, is what I need to know. And how could I do that? Yeah, Pythagorean theorem. This is a right triangle to our knowledge, right? It's got to be if these ratios hold true. So I could say that, I'll call it A for adjacent. A squared plus 3 roots of 13 squared is equal to 13 squared. A squared plus, now careful right here, I'm going to have this square apply to both of these factors here, so to speak. So 3 squared is 9, and the square root of 13 squared is 13, equals 13 squared is 169. So A squared equals, let's see, what's that going to be, 117? Did I do that right? 10 times 13 would have been 130. So 9 times 13 is 13 less than 130. I think that makes sense. A squared equals, let's see, subtract 117 from both sides. What's this going to be? This is going to be 52. I like it, I like it. And now I could root both sides. That's not 5 squared, that's 52. Technically, I'd have to plus or minus this, but because this is a dimension here, a distance, I'm anticipating this is going to be positive. So I'll have a is equal to the square root of 52. 4 goes into that, which is a perfect square, and it goes in, I believe, 13 times, right? 4 suits of 13 in a deck of 52. That's how I always remember those factors. So a is equal to the square root of 4 is 2, so 2 square roots of 13. Now, that's not my final answer, because they wanted what the secant from theta was. So this, I just found out, was 2 square roots of 13. So my secant theta is going to equal the hypotenuse, which is 13, divided by 2 square roots of 13. Right? Yeah, I think so. Yeah, all right. I was looking at this and thinking that was supposed to be the answer, but that's not. So that's why it was throwing me off. I was like, that's not going to happen. But that's fine. So to get rid of the radical, I can't simplify anything else just yet. Multiply by rad 13 over rad 13. And I'll get equals 13 roots of 13 over 2 times, and root 13 is 13. And I'm not even multiplying 2 times that because I realized this happens. So I'm going to get secant theta equals root 13 over 2. All right? So drawing a picture is definitely going to be helpful. A lot of times you can relate it back to that and you'd be able to solve it just fine. So thanks for watching, Internet friends. Bye-bye.